Hello my dear students, welcome to chemistry classes. Okay, so before starting this the concept video, I want to tell something. Dear students, ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಈ ವಿಡಿಯೋದಲ್ಲಿ ನಾನು ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ಸೊ ದಟ್ ಈಸ್ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ಯುವರ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮಿನೇಷನ್. ಡೆಫಿನೆಟ್ 3 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಬರುತ್ತೆ, ಹೌದಾ? ಸೊ ಇಲ್ಲಿ ಒಂದು 3 ಡೆರಿವೇಷನ್ಸ್ ಇದೆ. ಐದರ್ ಒನ್ ವಿಲ್ ಕಮ್ ಫಾರ್ ಯುವರ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮಿನೇಷನ್ ಡೆಫಿನೆಟ್ಲಿ, ಹೌದಾ? ಯಾವುದೋ ಎವ್ರಿ ಇಯರ್ ಏನು ಮಾಡ್ತಾರೆ ಅಂತಂದರೆ ಅಲ್ಟರ್ನೇಟ್ ಡೆರಿವೇಷನ್ಗಳನ್ನು ಕೇಳ್ತಾ ಹೋಗ್ತಾರೆ, ಹೌದಾ? ಸಮ್ಟೈಮ್ಸ್ ಸೇಮ್ ಡೆರಿವೇಷನ್ ಮೇ ಬಿ ಆಸ್ಕ್ಡ್ ಅಗೇನ್ ಆ್ಯಂಡ್ ಅಗೇನ್. ಸೊ ಆ ಕ್ಯಾಟಗರಿಯಲ್ಲಿ ಬರುವಂಥ ಒಂದು ಡೆರಿವೇಷನ್ ಇದು 3 ಮಾರ್ಕ್ ಇಂಪಾರ್ಟೆಂಟ್ ಡೆರಿವೇಷನ್. ಸೊ ಇದಕ್ಕಿಂತ ಮೊದಲು ಏನು ಮಾಡಿರ್ಬೇಕು ನೀವು, ಯು ಶುಡ್ ವಾಚ್ಡ್ ಬೈ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಸ್, ಹೌದಾ? ಸೊ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಗಳು ನೀವು ನೋಡಿಲ್ಲ ಅಂತಂದರೆ ಈ ವಿಡಿಯೋ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಬಾಕ್ಸಲ್ಲಿ ಇದರ ಲಿಂಕ್ ಇದೆ, ಪ್ಲೇಲಿಸ್ಟ್ ಲಿಂಕ್ ಇದೆ. ಪ್ಲೀಸ್ ಗೋ ಟು ದ ಪ್ಲೇಲಿಸ್ಟ್ ಆ್ಯಂಡ್ ವಾಚ್ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಸ್, ಹೌದಾ? ಸಪೋಸ್ ನೀವು ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋ ನೋಡಿದಿರಿ ಅಂತಂದರೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ, ಬಟ್ ಕ್ಲಿಯರ್ ಆಗೋದಿಲ್ಲ, ಹೌದಾ? ಸೊ ಅದಕ್ಕೆ ಏನು ಮಾಡಿರಿ, ನನ್ನ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಗಳನ್ನ ನೋಡಿ ಈ ವಿಡಿಯೋನ ನೋಡಿ, ಹೌದಾ? ಸೊ ಇಟ್ಸ್ ವಿಲ್ ಬಿ ವೆರಿ ಹೆಲ್ಪ್ಫುಲ್ ಆ್ಯಂಡ್ ಡೋಂಟ್ ಫಾರ್ಗೆಟ್ ಟು ಸಬ್ಸ್ಕ್ರೈಬ್. ಓಕೆ, ಫಸ್ಟ್ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ, ದೆನ್ ಇಫ್ ಯು ಫೈಂಡ್ all our videos are helpful, please share among your friends. Okay, next come to the points. Here we are going to discuss today the most important concept, the integrated rate equations. Integrated rate equations. So ಇಲ್ಲಿ ತನಕ ಏನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ನಾವು, we have discussed about only the rate equations or rate law, rate expression of a chemical reaction, and we have also discussed about rate of a chemical reaction, isn't it? And so what is the meaning of integrated rate equation? So integrated rate equation ಅಂದ್ರೆ ಏನು, what is the use and what are the importance of the integrated rate equation ಅಂತ ನೋಡೋಣ. First, if I want to calculate rate of any chemical reaction, ನಾನು ಯಾವುದೋ ಒಂದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಏನು ಮಾಡಬೇಕು, ರೇಟನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು, ಹೌದಾ? ಇದಕ್ಕಿಂತ ಮೊದಲು ನಾನು ಇಂಟಿಗ್ರೇಟೆಡ್ ರೇಟ್ ಇಕ್ವೇಷನ್ ಗೊತ್ತಿಲ್ಲ. ಇದಕ್ಕಿಂತ ಮೊದಲು ನಾನು ಏನು ಮಾಡಬೇಕಾಗಿತ್ತು, I should perform an experiment, isn't it? Now I should take a reactant and I should add some reagent and I have to watch the whole chemical reaction stepwise, and I have to count the total time taken for that reaction. Based on that I have to plot a graph, isn't it? The consumption of the reagent or for decreasing the concentration of reactant or increasing the concentration of product versus time. On plotting the graph I have to consider 2 points, and in between those 2 points I have to calculate average rate of that reaction, isn't it? So ಆ ಮೆಥಡ್ ಇಂದ ಏನು ಮಾಡ್ತಿದ್ವಿ ನಾವು, ಎವರೇಜ್ ರೇಟ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿದ್ದೀವಿ. ರಿಯಾಕ್ಷನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಿದ್ದೀವಿ, ಪ್ರತಿ ಸ್ಟೆಪ್ ಅನ್ನು ನೋಟ್ ಮಾಡ್ಕೋತಾ ಹೋಗ್ತಿದ್ದೀವಿ. ಯಾವ ಟೈಮ್ಗೆ ಎಷ್ಟು ರಿಯೇಜೆಂಟ್ ಕನ್ಸಂಪ್ಷನ್ ಆಗುತ್ತೆ, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ ಎಷ್ಟು ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ ಎಷ್ಟು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಅದನ್ನೆಲ್ಲ ನೋಡಬೇಕಾಗಿತ್ತು. ಆಮೇಲೆ ಅದನ್ನ ಏನು ಮಾಡಬೇಕು, ಗ್ರಾಫಿಕಲಿ ಪ್ಲಾಟ್ ಮಾಡಬೇಕು, ಗ್ರಾಫ್ ಹಾಕಬೇಕು, ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ವರ್ಸಸ್ ಟೈಮ್ ಗ್ರಾಫ್ ಹಾಕಬೇಕು. ಆ ಗ್ರಾಫ್ ಏನು ಮಾಡಬೇಕಾಗಿತ್ತು, ನಾವು ಎವರೇಜ್ ರೇಟನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿತ್ತು. ಸಪೋಸ್ ನನಗೆ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ರೇಟ್ ಬೇಕಾಗಿತ್ತು ಅಂತಂದರೆ, ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಅಟ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್, ಆ ಗ್ರಾಫಲ್ಲಿ ಏನು ಮಾಡಬೇಕಾಗಿತ್ತು ನಾನು, at a particular point I have to draw a tangent and the slope of the tangent will give the instantaneous rate of reaction. It's not an easy process, isn't it? Idella ಅಷ್ಟು easy process ಅಲ್ಲ. And to understand the order of reaction and the ideas of that reaction, the further information of that reaction were given by the experimental data only, ಹೌದಾ? ಸೊ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದಾಗ ಮಾತ್ರ ಏನು ಗೊತ್ತಾಗಿತ್ತು ನಮ್ಗೆ, ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಗೊತ್ತಾಗ್ತಿತ್ತು, ಆಮೇಲೆ ರೇಟ್ ಲಾ ಬರೀಬೇಕಾಗಿತ್ತು, ಈ ಥರ ಎಲ್ಲ ಮಾಡಬೇಕಾಗಿತ್ತು. ಇಟ್ಸ್ ನಾಟ್ ಅ ಈಸಿ ಪ್ರೊಸೆಸ್ ಆ್ಯಂಡ್ ಇಟ್ಸ್ ಆಲ್ಸೋ ಲೆಂದಿ ಆಲ್ಸೋ. ಟು ಅವಾಯ್ಡ್ ದಟ್ ಕನ್ಫ್ಯೂಷನ್, ಅದೆಲ್ಲ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಅಷ್ಟೆಲ್ಲ ಮಾಡಬೇಕಾದ್ರೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಟು ಅವಾಯ್ಡ್ ದಟ್ ಕನ್ಫ್ಯೂಷನ್ ಆ್ಯಂಡ್ ಟು ಅವಾಯ್ಡ್ ದಟ್ ಲೆಂದಿನೆಸ್ we should go for integrated rate equation. So these are the simplified form of the rate equations, very simplified form. ಈ ಇಕ್ವೇಶನ್ ಏನಂತಂದ್ರೆ, the differential rate equation is integrated. ನಾವು ಜನರಲಿ ಏನು ಬರೀತೀವಿ, differential rate equation ಬರೀತೀವಿ. You can write differential rate equation for the particular reaction. The differential rate equations are integrated to get a new equation which gives a relationship between directly measured data. Directly measured data means what? Directly measure, ಏನು measure ಮಾಡ್ತೀವಿ ಡೈರೆಕ್ಟ್ ಆಗಿ, you can measure concentration of reactant or concentration of product. Directly measured data and rate constant is called as integrated rate equation. Simply integrated rate equation ಅಂದ್ರೆ ಏನು, these are the equation which gives the relationship between directly measured data means concentration of reactant and rate constant. ಈ ಇಂಟಿಗ್ರೇಟ್ ರೇಟ್ ಇಕ್ವೇಶನ್ ಏನು ಯಾವ ತರ ಡಿರೈವ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ನಾವು ಫಸ್ಟ್ ಏನು ತೋತೀವಿ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ತೋತೀವಿ ಅಂಡ್ ದೋಸ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ಸ್ ಆರ್ ಇಂಟಿಗ್ರೇಟೆಡ್ ಆಗೋಣ ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಇಂಟಿಗ್ರೇಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ ಇಂಟಿಗ್ರೇಷನ್ ಮೀನ್ಸ್ ವಾಟ್ ಸಮ್ಮಿಂಗ್ ಸೊ ಆನ್ ಇಂಟಿಗ್ರೇಟಿಂಗ್ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಅ ನ್ಯೂ ಇಕ್ವೇಶನ್ ಆ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ಅನ್ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದಾಗ ಏನು ಸಿಗುತ್ತೆ ನಮ್ಮದು ಹೊಸ ಇಕ್ವೇಶನ್ ಸಿಗುತ್ತೆ ಸೊ ದಟ್ ನ್ಯೂ ಇಕ್ವೇಶನ್ ಗಿವ್ಸ್ ದ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ ಅಂಡ್ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆ ಹೊಸ ಇಕ್ವೇಶನ್ ಏನು ಕೊಡ್ತಂದ್ರೆ ನಮಗೂ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ಗೂ ಮತ್ತು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ಗೆ ಏನು ಸಂಬಂಧ ಇದೆ ಸೊ ಆ ರಿಲೇಷನ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೊಟ್ಬಿಡುತ್ತೆ by using that we can calculate order of reaction molecularity of reaction and all other things very much easily so ಉಳಿದ ಎಲ್ಲಾ ಇನ್ಫಾರ್ಮೇಷನ್ ಏನು ಮಾಡಬಹುದು ನಾವು ಈಜಿಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು so these are the simplified version of our experimental data okay ನಾವು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದಾಗ ಏನು ರಿಯಾಕ್ಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿಲ್ಲ ಅವನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಇಂಟಿಗ್ರೇಟ್ ರೇಟ್ ಇಕ್ವೇಶನ್ ಅಂತ ಬರೀತೀವಿ so these integrated rate equations are different for different order of reaction this is important for all the reactions the integrated rate equation is not constant the integrated rate equation is different for different order of reaction so order of reaction change ಆದಾಗೆ ನಮಗೆ ಏನಾಗುತ್ತೆ integrated rate equation ಏನಾಗುತ್ತೆ change ಆಗುತ್ತೆ so it changes with the order of reaction so here so for your syllabus so there are only two derivations the first one integrated rate equation for zero order reaction and one more is integrated rate equation for first order reaction okay so let us derive integrated rate equation for zero order reaction first em modana zero order reaction em modana derivation modana so derivation is very simple so if you practice for more than 5 times it will remain in your mind forever for up to your second PUC examination okay a zero order reaction means what a zero order reaction means the rate of the reaction is independent of the concentration of reactant isn't it so a zero order reaction means that the rate of reaction is proportional to zero power of the concentration of reactant so zero order reaction the rate of the reaction is proportional to the zero power means what zero anything raised to 0 means what 1 only so proportional to 0 power of the concentration of reactant let us consider the reaction so this is our chemical equation R indicates reactant P indicates product formed in the reaction so R gives rise to product reactant gives product here for this how we can write equation rate of reaction rate is equals to differential rate I have to write differential rate for this minus dr divided by dt is equals to k into concentration of reactant raised to 0 anything raised to 0 means what 1 so this whole entire term becomes equal to 1 so now minus dr by dt is equals to k into 1 means what k so this is our differential rate equation for zero order reaction what does this indicate for zero order reaction rate of reaction is equals to rate constant isn't it okay so now let us do some rearrangements so here I'll send this minus sign to this side what happens here minus comes this side it becomes minus k and dt also comes this side it becomes multiplication with k so dr is equals to minus k into dt ನಾನು ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ದೀನಿ ಅಂತಂದ್ರೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಈ ಕಡೆ ಕಳಿಸಿದ್ದೀನಿ ಆಮೇಲೆ dt ನ ಈ ಕಡೆ ತಗೊಂಡು ಬಂದಿದ್ದೀನಿ ಇಲ್ಲಿ ಡಿವೈಡ್ ಇದೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆಗುತ್ತೆ so now dr is equals to minus k into dt let us call it as equation number 2 ಇದನ್ನ ಏನು ತಗೊಂಡು ನಾವು ಈಗ equation 2 ಅಂತ ತಗೊಂಡ ಹೌದಾ and integrating this equation I have to integrate this equation 2 on integration both side ಇದನ್ನ ಏನು ಮಾಡ್ತೀನಿ ನಾನು ಎರಡು ಸೈಡ್ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡ್ತೀನಿ integration of dr is equals to minus k into integration of dt Why minus k is kept outside? Constant. So we cannot integrate constant. In integration and differentiation, the variables are only differentiated and integrated. So here integration of dr is equals to minus k into integration of dt. Here integration and differentiation cancelled out, isn't it? Integration and differentiation is cancelled out, so it becomes r is equals to minus k as it is integration of dt. So it is just like integration of x dx is equals to what? Integration of integration of 1 into dx. Integration of 1 into dx is nothing but x. So like that, integration of dt gives t plus I. Here I is the constant of integration. Here I is the constant of integration. Integration of dx is equals to x plus I. Here I is the constant of integration. In some texture we use c. In the place of I we can write c also. C is also constant of integration, where I is the constant of integration. Okay. Next, at a time t is equals to 0. T is equals to 0 means what? For this reaction, t is equals to 0 means what? Before the starting of reaction. Reaction start ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು at time t is equals to 0 ಅಂದ್ರೆ ಏನು? Reaction ಅನ್ನು ಸ್ಟಾರ್ಟ್ ಮಾಡಿಲ್ಲ. ಸ್ಟಾರ್ಟ್ ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು ಅವಾಗ ಏನಾಗುತ್ತೆ ನಮಗೆ? The concentration of reactant is equals to what? Initial concentration. Maximum ಇರುತ್ತೆ ಹೌದಲ್ಲ ಅದು? So here R is the concentration of reactant, R naught is the initial concentration of reactant. Initial concentration of reactant. So initial concentration ಯಾವಾಗಿರುತ್ತದು? Reaction start ಆಗೋಕ್ಕಿಂತ ಮೊದಲು. So at time t is equals to 0, when the reaction is not yet started, in that condition R is equals to R naught. Let us put these values in the equation 3. Let us put t is equals to 0 and r is equals to r naught in this equation, equation number 3. Now equation 3 becomes, here r becomes r naught minus k into t means what? 0. So r naught is equals to minus k into 0 plus I. K into 0 means 0 it is. So therefore it becomes I is equals to r naught. We got the value of I. Namagen sikti ga value of I siktu. And so we can use the value of I in equation number 3. Equation 3 ಅಲ್ಲಿ ಏನು ಮಾಡಬಹುದು ನಾವು? Value of I ಅನ್ನು place ಮಾಡಬಹುದಾ? Put the value of I in equation number 3. In this equation I will put the value of I. I means what? R naught. In the place of this I will place R naught. R is equals to minus KT plus R naught. So this becomes equation number 4. This is our equation number 4. And on rearrangement, here what I am going to get, I want a relationship between, direct relationship between rate constant and the concentration of reactant. So ನಮಗೆ ಏನು ಮಾಡೋಕೆ ಈಗ ಈ equation ನ k is equals to ಮಾಡಬೇಕು. So because of that reason I will rearrange minus kt. Minus kt ಇಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ, ಇದನ್ನ ಈ ಕಡೆ ಕಳಿಸ್ತೀನಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ ಇದು? R naught becomes minus R naught, and I will take out minus as a common. So now it becomes R naught minus R. Minus ಹೊರಗಡೆ ಬರುತ್ತೆ, minus minus ಏನು ಮಾಡ್ತೀನಿ ನಾನು? ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ತೀನಿ. Then k is equals to R naught minus R. If t comes this side, it becomes divide. K is equals to R naught minus R divided by t, where k is rate constant, R naught is the initial concentration, R is the concentration at time t, and t is the time. So this is equation number 5. I will call it as equation number 5, and this equation 5 is called as integrated rate equation for zero order reaction. So this much is the derivation. If they asked for 3 mark derivation, derive the integrated rate equation for zero order reaction. So you have to derive up to this. ಇಲ್ಲಿ ತನಕ derivation ಮಾಡಬೇಕು. For this you are going to get 3 marks. Simple, very simple. ಈ simple step ಗೆ 3 marks ಬರುತ್ತೆ. ಹೌದಾ? Okay. And so let us grab some more information from this. ಇದರಿಂದ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇನ್ಫಾರ್ಮೇಷನ್ ತಗೊಳ್ಳೋಣ. ಈ ಈಕ್ವೇಷನ್ ಇಂದ ನಾವು ಏನೇನು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬಹುದು ಅಂತ ನೋಡೋಣ. So let us draw a graphical representation of this equation. ಈ equation ಗಳನ್ನ, ಈ integrated equation ನಾವು ಗ್ರಾಫಿಕಲಿ ಹೇಗೆ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡಬೇಕು. So this is important for your JEE, NEET and KCET, and also for all type of competitive examination, because in theory they will ask for integrated rate equation and they will ask for only derivation of integrated equation, but for competitive examination they may ask graphical representation, how the graph is derived, how the graph can be represented, and they may ask problems based on this equation. Okay, so let us graphically represent this integrated equation of zero order reaction. From equation 4, here equation 4 is of the form, where is our equation number 4? So this is our equation number 4. Let us take equation number 4. Equation 4 is of the form y is equals to mx plus c. So what is this y is equals to mx plus c? This is the equation of straight line. Equation of straight line, isn't it? Y is equals to mx plus c. So if we draw the graph of y versus x, you are going to get a straight line with slope m and intercept c. See here, let us compare this equation with that y is equals to mx plus c. How we can compare? So let us compare like this. I will write here y is equals to m. Here the variables are this concentration of R is variable and T is variable. K is constant and initial concentration is also constant. So there is a possibility of drawing a graph of, we can plot the graph of R versus T. So let us take it as y. Here R is our y and T is our x. So we can draw the plot of R versus T. R along y axis, T along x axis. So what is our K? K is our m and this is our intercept, isn't it? So if you draw the graph like this, if I draw the graph like this, I am going to get a straight line with slope minus k, negative slope. For negative slope, graph will be like this, decreasing curve. Okay, so I got the graph like this. The slope of this graph is equals to minus k and this is intercept. Intercept is equals to r naught. So like this you can draw the graphical representation of the integrated equation of zero order reaction. And let us see the examples of zero order reaction. Which reactions are zero order in nature? Almost all enzyme catalyzed reactions are zero order in nature. Please remember, almost all, maximum number of enzyme catalyzed reactions are. Enzyme catalyzed means the reactions which are taking place biochemically. They all are enzyme catalyzed reactions. They all are zero order reactions. And the reaction which is taking place on the surface of metal. Which reaction takes place on the surface of metal? When the metal is used as a catalyst, then you can consider that as a zero order reaction. For example, decomposition of ammonia on the hot platinum surface is the example of zero order reaction. Why it is zero order reaction? So see here, for this reaction 2NH3 gives N2 plus 3H2. The temperature must be maintained around 1130 Kelvin, and this reaction takes place over the surface of hot platinum. Here for this rate is equals to K into the concentration of ammonia raised to 0 is equals to what? Anything raised to 0 is equals to 1. So this will be K only. And one more example is decomposition of hydrogen iodide on the surface of gold. See here, I will explain how these reactions are zero order reaction. So let us take, this is our platinum surface. Actually it is very small in nature, but I will consider, just zoom it. Okay, so this is the surface of platinum. On this surface our chemical reaction is taking place. Which reaction? The decomposition of ammonia. Okay, first the reaction takes place like this. Here ammonia molecules come here and they will deposited or adsorbed on the surface of this catalyst, and the chemical reaction takes place. The ammonia is decomposed and the decomposed components are nitrogen gas and hydrogen gas, and they will leave the surface as a gas. Okay, first ಏನು ಮಾಡ್ತಾವೆ ಅಂದ್ರೆ ಅಮೋನಿಯಾ ಮಾಲಿಕ್ಯೂಲ್ಗಳು ಬಂದು ಇಲ್ಲಿ ಅಡ್ಸಾರ್ಬ್ ಆಗ್ತವೆ, ಹತ್ತೊಂದು ಕೂತ್ಕೊಂಡ್ಬಿಡ್ತವೆ, ಇದಕ್ಕೆ ಇದ್ರ ಮೇಲೆ ಕೂತ್ಕೊಂಡ್ಬಿಡ್ತವೆ. ಆಮೇಲೆ ಅಲ್ಲಿ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ. ರಿಯಾಕ್ಷನ್ ಆದ್ಮೇಲೆ ಏನಾಗಿರ್ತಾವು, ರಿಯಾಕ್ಟೆಂಟ್ ಇದ್ದು ಪ್ರಾಡಕ್ಟ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿರ್ತವೆ. ಆಮೇಲೆ ಏನಿರ್ತಾವು, ಗ್ಯಾಸಸ್ ಇರ್ತಾವಲ್ಲ, ಸೊ ರಿಮೂವ್ ಆಗಿ ಹೊರಗಡೆ ಹೋಗ್ಬಿಡ್ತವೆ. ಹೌದಾ? ಸೊ if I take 100 molecules, 100 molecules will accumulate on the surface of this catalyst, and they will convert it into product, and they will leave the surface for other accumulation. Okay, if I take 200 molecule, then what happens? If I take 200 molecule, first the 100 molecules will accumulate and they are converted into product and they will leave the surface. For this, if it takes 1 minute for the conversion of 100 molecules, if it takes 1 minute, the 100 more molecules are waiting for this. Okay, if I consider 300 molecules, what will happen? First 100 molecule will accumulate, and for this conversion I want only 1 minute time. On 1 minute time, 100 molecules are converted into product and they will leave the surface. Here the molecules which are waiting are 200. If it is 300, they also wait for 1 minute. If they are 400, they also wait for 1 minute. So like that, the rate of reaction is independent on the concentration of reactant. ಹೌದಲ್ವಾ? ಸೊ ನಮಗಲ್ಲಿ ನಮ್ಮ ರಿಯಾಕ್ಟೆಂಟ್ ತಗೊಂಡಂತ ರಿಯಾಕ್ಟೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ ಎಷ್ಟು ಬೇಕಾದಷ್ಟು ಇದ್ರು ರೇಟ್ ಏನಿರುತ್ತೆ, ಇಲ್ಲಿ ಈಕ್ವಲ್ ಇರುತ್ತೆ. ಯಾಕೆ ಈಕ್ವಲ್ ಇರುತ್ತೆ ಅಂದ್ರೆ, ಸಪೋಸ್ ಈ ಸರ್ಫೇಸ್ ತುಂಬಾ ಎಲ್ಲ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಕ್ಯುಮುಲೇಟ್ ಆದವು ಅಂತಂದ್ರೆ ಹಿಂದ್ಗಡೆ ಬರುವಂತ ಮಾಲಿಕ್ಯೂಲ್ ವೇಟ್ ಮಾಡಲೇಬೇಕು ಈ ರಿಯಾಕ್ಷನ್ ಆಗೋ ತನಕ. ಹಿಂದ್ಗಡೆ ಇರುವಂತ ಮಾಲಿಕ್ಯೂಲ್ 10 ಮಾಲಿಕ್ಯೂಲ್ ಇದ್ರೆ ವೇಟ್ ಮಾಡಬೇಕು, 20 ಮಾಲಿಕ್ಯೂಲ್ ಇದ್ರೆ ವೇಟ್ ಮಾಡಬೇಕು, 30 ಇದ್ರೆ ವೇಟ್ ಮಾಡಬೇಕು. ಇಫ್ ದೇ ಆರ್ 1000, 10,000, whatever, if there are million molecules, they have to wait for the completion of this reaction. So because of this reason, the rate of reaction is independent on the concentration of reactant. artha aydala idu? So this is about the integrated rate constant of zero order reaction. So please remember, practice this well and keep it in your mind. Okay, thank you.